now looking at target 6.6, I can use the distance formula to classify triangles. Okay? So what does that mean? Well, we have three main different types of triangles that are classified by their sides. You could also classify triangles by angles, but we are not worrying about that this unit. So our three different types of triangles are scalene, isosceles, and equilateral, if we're classifying by their sides. So a scalene triangle is a triangle, a triangle that has three different side lengths. Okay. So for example, if I draw here, let's say, pretend these connect. So there's a triangle. We have like 7, 5, and 2. All right, all three numbers are different, and that makes it a scalene triangle. Okay. Then we have an isosceles. An isosceles triangle is a triangle that has at least two sides congruent. So if this is 5 and 5 and 3, these are my congruent sides. All right, that is an isosceles triangle. Our last type of triangle is equilateral. And an equilateral triangle is a triangle that has all three sides congruent. My triangles aren't becoming triangles. So if all those were exactly the same length, that is an equilateral triangle. The equilateral triangle is a special case of isosceles. If I have all three sides congruent, it means I have at least two sides congruent. It just so happens the third one is congruent too. So that third side doesn't have to be congruent for an isosceles triangle, but if it is, it's still isosceles. Okay, so equilateral is just like a special isosceles triangle. However, when we're classifying, like in example 1, we want to be as specific as possible. Okay, so if it is equilateral, don't say isosceles. Make sure, like, you say that, oh, wait, this is a super special equilateral triangle. Okay? So in our examples, we're going to classify each triangle as scalene, isosceles, or equilateral. In order to do that, I need to know the length of the sides. This is going back to what we did. If I can find the distance of each side, find the length, right? Then I can see if they're the same. All right. So it doesn't really matter which side you start with, but let's start with this side. And again, find that distance. We're going to use Pythagorean's theorem, so I'll draw a lovely right triangle, right with that side as the hypotenuse. So we have 2 and then 1, 2, and 8. So a squared plus b squared equals c squared. 2 squared, that's not squared. 2 squared plus 8 squared is our c squared. Alright, so we have 4 plus 64, and 4 plus 64 is 68. So c equals the square root of 68. You can find the decimal, but this should be good enough. Okay. So for perimeter, you have to find the decimal. For these ones, you can just keep it exactly how it is. You don't even have to simplify it, because I'm just checking if they're the same or not. Okay. All right, so now I'm going to do my next side of the triangle. All right, and again, we make a right triangle off of it with that line as the hypotenuse. So we have a 3 here and 6 here. So again, we have a squared plus b squared equals c squared. And that's 3 squared plus 6 squared equals c squared. And that's 9 plus 36. And then that's 45. Square root both sides, c equals the square root of 45. Well, the square root of 68 and the square root of 45 are not going to be equal. So I already know it's not equilateral, right? But we do have to find our last side. And this diagonal. 1, 2, 3, 4, 5. So we have 4 squared plus 5 squared. That's 16 plus 25. And that is 35, 41. Okay. So now if we look, we have 3 different sides. So we have 3 different sides. So that means that it's scaling. And that is it. Pretty simple, right? It's just using our distance formula, which we already know and have practiced a lot. Or our distance formula, which we use as Pythagorean's theorem. All right. 2 more examples. Looking at this one, right? So I'm going to do the same thing. We have this side. And it goes up 2 over 2. So I'm going to do 2 squared plus 2 squared equals our c squared. 4 plus 4 equals c squared. 8 equals c squared. And I take the square root, and so I get c equals the square root of 8. Looking at this blue side, it goes over 3. 1, 2, 3, 4, 5. So we have 3 squared plus 5 squared equals c squared. 9 plus 25. That's 34. So when I take the square root, we get that c equals the square root of 34. All right, our last side is this green side. Well, this is also 3 and 5. I'm not going to go through all the work again, right? We already did it. Okay, so again, use like the symmetry, use those equal things to your advantage. Okay, where if you have the same two numbers, you don't really have to do you don't have to do your whole Pythagorean theorem again. Okay. So now this has two equal sides, and that makes it isosceles. All right, looking at our last one. Starting with A to B, it goes up 1. Up 5 over 3. This is going to be the same work as our previous problem, but in a new problem, we should show this again. It's only in like the same problem that we don't have to redo the work. 5 plus 9 is 34. Oh, hold on. So then C equals the square root of 34. And on our next triangle, we're looking at this side. We have over 3. Again. Now we can use that, hey, look, those are the same numbers. Then again, remember, for a side that's not a diagonal, we just count across, right? So we have 1, 2, 3, 4, 5, 6. I put C. You don't really have to. You're not really doing Pythagorean theorem, but to kind of compare, it's nice to do that. Right? So if they're straight across a line, you do not have to use Pythagorean's theorem. Now, the square root of 34 is very close to 6. If you see what that is, right? If we look here, if we take the square root of 34, we get 5.8. But it's not quite the same. So this is still technically, right, one side, two side, an isosceles triangle. All right, that is it. I will see you guys tomorrow. Have a great rest of your day.